Welcome everyone to the afternoon session of the ArcGIS conference. This hour we have two very intriguing talks. The first one will be brought to you by Eric Cylwik and Dean Miller. It's UAS as a construction tool. Please remember that you can open up your chat windows over on the right to chat, and then also put your questions and answers in that question and answer box. Those will be moderated in the question and answer box and will be answered at the end of each session. So I am going to turn it over to Eric and Dean.
Thank you so much, Teresa. I appreciate the setup there, and I'm very excited today to be able to take some time to brag about how Sant uses these technologies as a tool. And that's going to be the theme today that you hear from us. And as she mentioned, my name is Eric Cylwik. I'm the Director of Innovation at Sundt Construction and have had a long time involvement with our drone program. And we also have Dean Miller, who is currently leading our drone program. And so you'll be hearing from both of us during this session as we kind of talk about the different aspects and the different ways we've been involved with the program. But again, super excited to be here and to share that with you. And before we dive into any specific uses, I do want to take a moment and talk about how our drone program started and also how we've scaled it through the organization, because I think that's a critical part of the narrative, to be able to say, here's where we started and here's where we are. And that journey there is a really important piece of this. Through that context, we'll be talking about some of the integrated uses that we have with our job sites and with the front lines of our business to be able to help generate more value for us as builders and also for our clients as owners of these assets and the questions that they have with operating and maintaining their facilities. And then Dean's going to take some time to talk about the future of where we're headed with UAS operations, because it is going to look different in the future than it did 3-4 years ago. And it's going to look different in some very important ways for us as a business. So the evolution of the UAS program at Sant started in about 2015. At least that was the first time we had heard of people having drones and their pilot certificates here at Sant. That was the year that we realized we had 2 pilots, and then they each had their own drones. So 2 pilots, 2 drones, and they were using it to capture photos, to capture videos. It sounds kind of crazy, but there's actually a lot of moments in our industry where we will submit an invoice to a client and they will turn around and submit that invoice to their financing partner, whether that's a bank or some other capital company, right? And they'll say, well, how do I know you've actually put 60% of the roof on? And so we had some good luck early on being able to take a drone and snap a photo of the progress of the job, and it made it pretty clear cut as far as what we were billing and why we were billing. So we started to get some pretty early wins with the technology and really started to find some use cases for it. And believe it or not, turned out there were other folks in the company that were really interested in being able to get in and use some of these tools. By 2017, we had 7 pilots and we had 5 drones between those 7. We had some different versions of Phantoms now. And we also had in our marketing group a GoPro Karma drone. We were still doing the photos and the videos, but two of the new features that we added was scalable imagery and also 3D models. And those are important to us as builders because that scalable imagery meant we could go fly a job site and start to go in and take measurements. We could now quantifiably show how much of the roof we've installed or how much of a roadway we've graded. We would be able to easily share those through some of the web tools that we had purchased at that point in time. And then also be able to go in and create 3D models using some photogrammetry to be able to wrap our minds around the construction narrative. And you'll hear me use that term today, and it's my way to describe the construction process. Construction is really difficult because you have literally hundreds of people coming together for anywhere from the entire project to just a few weeks of their time on the project. You have hundreds of parts and pieces of equipment, and you're trying to capture all of that to tell somebody something specific, whether through aerial photography, you're showing the overall progress, or whether you're kind of getting in close and doing a particular inspection on a piece of equipment. It's a very difficult narrative to tell because it is so complicated and there's so many moving parts and components to it. In 2018, we had 13 pilots and 10 drones. So you're definitely seeing a trend here that we are growing and adding more to our fleet. We really started to focus in on engineered deliverables. We started to purchase drones that had a much closer connection to accurately placing themselves, and then also started to invest in some ways that we could do some ground control points to be able to tie in some additional data. We also started to kind of toy around with some 360-degree imagery to be able to go and grab a single spot on a job site and then allow somebody to be able to go in and look at anywhere from that particular viewpoint. We also invested in a Matrice 210, and that had the ability to have a thermal camera. So that way, after we finished a job, we could go and do some additional inspections from the exterior of the structure that really allowed us to gain some insights. And Dean will have some more context on some of those examples later. But between 2015 and 2018, we've gone from 2 pilots and 2 drones to 13 pilots and 10 drones. And that was about the moment in time where we realized we needed somebody to kind of help us understand and help us apply these things inside of our walls. That's where Dean was brought on board, and a huge portion of his effort at the company has been making sure that we've got the right controls and measures in place, helping write some of our policies, and making sure that all of our pilots are doing things that are great decisions and operating safely in the airspace over our jobs. To dive into some of these specific use cases, we are using the technology to be able to thread what I would call different versions of reality together, right? We have in this case, we have a video of a project, and we're flying where this project is going to be built. Our concrete group internally, whenever we go to pursue a project, they will create a digital 3D model of the project, and then we will tie it to a schedule that shows us what it's going to be like once we actually build it. It's taking a really complicated process of looking at a Gantt chart and understanding how that relates to the real world. We're able to visualize that all in the context of what is actually happening in the real world. So you can start to see how, in this case, a ramp to an underground parking structure might be interacting with an adjacent piece of infrastructure, or how things line up with adjacent buildings. But it takes something that's normally very difficult to unravel and difficult to wrap your mind around, and makes it very digestible, and something that really communicates a clear picture of what the construction narrative is going to look like, and demystifies a lot of that. We've also had a lot of luck with the idea that you can fly it and make a model of it. And again, the model is fantastic in its own right to be able to go in and do some of the things that Dean will talk about in a little bit. But again, focusing on that idea of, instead of just pulling in a real-time video and then overlaying the version of what the construction process is going to look like, we also mix realities the other way. So in this case, we flew the drone, built the model, and this one happened to use some ground control points to make sure that we had extreme accuracy on the data that came in here. But then we could overlay that with the digital coordination model that we had. So in this case, we were able to go in and look at some of the site excavation and some of the utilities and things of that nature around the job site. But we would fly the job on Monday, have a 3D model by Wednesday, and then we would look at it and review it as a team. And in this particular week, it allowed us to see that there was a retaining wall that still needed to be built. But if we had left the excavation slope as it was, it wouldn't have allowed us to be able to get in there and easily build that retaining wall footing. So instead of waiting until the moment when it was too late to do something about it, our superintendent was able to call our Earthworks subcontractor and say, hey, while you've got the scraper still out there, you actually need to push this slope back about 12 feet. So that way we've got room to be able to get in there and build out this retaining wall footing. And it's those kinds of things that raise awareness for us, that create value and allow us to take action to create more predictability and more certainty around the construction activities that we do. And we wouldn't be able to accomplish that if we didn't have that additional perspective, if we didn't have some mechanism by which we could sense the entire job site and then build a digitally accurate and spatially accurate model of those things to be able to coordinate and mix that stuff together. Dean, do you want to talk a little bit more about the specific quantity aspect of this?
Yeah, for sure. So after we're done capturing this reality, and creating an orthomosaic map and a 3D model out of it, we're able to go in and analyze exactly what this reality looks like at any given moment, when that drone flies at the project. And so in this case, we were able to go and fly this project immediately after Earthworks and be able to use our tools that we've been given and and use volumetrics and cut fill analysis to determine where exactly they have been digging, how much they've removed, which, you know, once you know how much they've removed, you know how much they should be appropriately billing us, and to know like the accuracy of it all. And this is important for a lot of aspects, to know where we're going to be actually placing the building, like Eric said, checking for banks and making sure that everything is in the appropriate location, but also checking for water runoff, right? We're checking elevations and making sure that when it rains, the water is going to run off to the appropriate place and not pool up somewhere on site. And none of this would be really possible if we weren't using ground control points. And I feel like that's something that's going to be said, but needs to be stressed more, is using actual ground control points that have an accurate XYZ location tied to them, and then processing the drone map utilizing those. So now we have something that's accurately geolocated, and something that we can measure off of, something that we can bring actionable data from. And that's a word, or that's a term that you're going to be hearing often from us, is actionable data. So you know, through this we can determine exactly what they've done, where they need to be, and ensure they're on schedule and that placements are going to be correct. And speaking of accuracy, when we fly a site, we need to know that all of the utilities are correct. And whether that's underground utilities or in slab utilities or MEP penetrations through a deck, they need to be correct, they need to be accurate. And so before we go and fly a job site, we will, or before, I'm sorry, let me repeat that. Before a slab is poured for our job, we'll go and we will fly that slab, and then we'll create an orthomosaic map, which is just a collection of, you know, hundreds of drone photos, and stitch them together. And through that, we can now overlay some of the drawings that we've been given to align with the actual data, or with the actual slab that's there, and ensure that all of our utilities, whether it's plumbing, electrical, or fire protection, whatever it is, we need to make sure that everything's in the correct location. And in this case, you can see that there's a lot of measurements around that elevator shaft within this slab. And so not only are we checking in placement, but once that slab is poured, now we can fly it again, and we can overlay the drawings onto the top of that slab, so that when we go to pour, or when we go to drill into the slab to connect stud walls to the slab, we can ensure that we're not hitting post-tension cables, we're not drilling through utilities or anything like that. So it's really two-dimensional or three-dimensional with two different aspects, and it's pre and post slab, ensuring that we're generating a good quality of work with what we're doing, and that we're not going to have to go back and either jackhammer out, you know, one plumbing line that could take days and cost us, let's say, $50,000. And the schedule moves forward. We stay on budget as well with this. And so this has proven to be very useful for us for both of those reasons, time and time again.
And Dean, I want to tack on too. You were describing the orthomosaic process of stitching those photos together. And back in 2015, we may have done some flights where we ended up taking some of the photos and dropping them into Photoshop, and then painstakingly trying to align them with some pretty ugly seams in between. And I think one of the fun threads that I'm seeing in regards to this technology is the automation of it. So that way you don't have to be a subject matter expert at stitching photos together, right? But we've got tools in place now that support pilots who don't need to be experts on these subjects, but are able to produce really, really great products out of their drone flights.
Absolutely. Thanks for that, Eric. So Eric has described the forward progression of our drone program, and where we are today is we've got 25 pilots and counting. We're always, it seems like we're adding a new pilot every month. It's such a needed skill set, and we've got about 20 drones in our fleet. We're creating 3D models with them, as you can see in the video to the side there. And what this allows us to do is it allows us to scan and generate a model with sub 1 millimeter accuracy, which is just incredible for using photogrammetry. This isn't LiDAR, this isn't laser scanning, this is just photogrammetry with a drone. And the way that these drones operate is they create a point cloud around themselves as they fly, and they're able to determine what exactly there is that it's looking at, that I'm asking them to inspect, and it is then creating a flight path around itself without any input from me. So this is purely on its own. It's a a flying supercomputer. It knows exactly where it is in time and space, and it's able to generate the kind of results that we need. And this is huge for a lot of reasons. So this what we're looking at right now is called a crystallizer, and it takes superheated water and cools it effectively. And if for us to have a drone do an inspection that traditionally would take 1 or 2 people to go through is hugely beneficial because of safety alone, right? Not to mention the time savings, but just having a piece of machinery that to simplify it, a flying piece of plastic with a camera attached to it, right? To have this simple piece of machinery go through and generate such a high quality model is incredible for us moving forward, because now we don't have to put 1, 2, 3, however many people in here to do this inspection, put them potentially in harm's way around this very temperamental or volatile equipment. So it brings a new aspect to what we're doing and how we're doing things within construction industry as a whole. And now we wanted to talk to you a little bit more about, what we're planning on doing in the future. And going back to that perfect slide, or that previous slide, is bringing these 3D scan models that have this sub 1 millimeter accuracy into the entire model as a whole. So that, the video you saw is just one portion of an entire project site. And if we're able to capture that entire project site in one high definition, high detail model, it brings a different aspect to what we're doing. We're effectively able to capture exactly where we are and exactly what we're doing with very to little blur or smearing from stitching together those photos. And that brings a lot of benefits to Sant, because we're able to use that for litigation, or for billing, or for progress reports, quality inspections, quality analysis, and everything that goes with that. Another thing that we're pushing for is being able to fly drones from a remote location. Right now, that the laws that are in place are that the drone cannot leave the pilot's visual line of sight. That it has to stay within visual line of sight before the drone has to be brought back home, and that's a barrier that we're looking to overcome in accordance with the FAA. So it's not anything that's too crazy, but right now we're experiencing more demand for drone flights than we have pilots or drones, right? These demands are exceeding our capabilities. And in order for us to effectively scale our drone program, we have found that there's a company called Skydio. They're a drone manufacturer. They have a solution called Drone in a Box, or a docking station, as they call it. And it allows me from my office in Tempe to fly a drone, whether it be somewhere else in Tempe or Phoenix or in Texas or California. I am able to launch that drone out of the box, fly the site, and return it to that box, and then process all that information without ever having to leave my desk. And so that's something that we're working with them on, and that we're hopefully testing here soon, so that we can bring this into reality. The last thing is, well, not the last thing, but something we're pushing for is 3D models of interior of buildings. I've said it a lot of times, but the videos, those photos are really great for owners and clients to see exactly where we're at, or even banks to make sure that we're billing appropriately. But the models that are generated from this are what's of value to our project teams. We want we want actionable data from our models that we can measure off of, that we can utilize, that we can integrate into BIM management, and bring this reality into our 3D world, and effectively base our actions off of that, and try and predict the future as to what's going to happen next, and relay that to our field team. And the video you just saw was the use of thermal drones during a closeout of a project. We'll take a thermal drone and fly the drone at night, and whether it's cold outside and we're blasting the heat inside the building, or it's hot outside and we're blasting the air conditioning, we're then able to determine where the energy is escaping from this building, whether it's out of the utilities on the roof, like you're seeing here with the HVAC. You can see those red hot corners there, or if it's out of the facade, or a window wasn't sealed properly. We're able to see that energy escaping. We're able to fix that problem, relay that information to our subcontractors so it can be fixed. And then it also gives us a very accurate point in time of when we handed over a building to our client, what that building looked like, both physically and thermally, and keep that for litigations down the road between us and the client.
Another big thing that we're leaning on in the future, Dean mentioned that there is enough value out on our job sites to be gained from these UAS operations, and we have not enough folks to be able to do that, right? One of the partners that we're working with at the moment has the ability to have a lot of AI and kind of remote functions. And Waymo, who does autonomous rideshare vehicles, has kind of their slogan as the world's best driver. And I think we are starting to lean on some of these other things as kind of the world's best co-pilot, right? Like we're at a point where, hey, we need these on the job sites, and it lowers some of our cost of training, it lowers some of our costs in other places as well, to be able to provide certainty around the missions that they're conducting, that they're safe, that they're accurate, and that they meet the requirements in order to be able to produce the right deliverables. And so as we see that become more and more embedded with those technologies, I think we're going to see that barrier to entry go lower and lower. With that being said, I don't see it impacting the way that we are certifying our own pilots internally. One of the things I left out in the drone program development slide is when somebody at Sant receives their Part 107 certification, even though they've already passed the airman knowledge test, Dean actually meets with them, puts them through some additional tests, and has them demonstrate operational excellence before they are able to go and fly a drone over one of our job sites, just because they do tend to be areas of lots of activity, and we need to make sure that they are safe. But being able to lean on some additional support is going to be important moving forward. And as we're able to do that, we're going to be able to leverage this technology to sense more of our job sites, to be able to get higher up, to be able to sense these things and build out a better understanding. So that way we can have more and more actionable data. Some of those use cases that you've seen don't happen on every project because it's not quite there yet. But as we march towards that, it does become more and more accessible. And as Dean mentioned, we're talking about using these in moments where there's a high risk activity or a high risk scope, meaning that instead of sending somebody in who might be exposed to some sort of risk or environmental hazard, we can use these drones to kind of deploy and investigate. And then we also create that video or photo archive to be able to have that further down the road as that project is used.
Yeah, exactly, Eric. I like the way you phrased that. And, you know, in this line of thought, that, you know, beyond visual line of sight is important to us because it allows us to effectively scale and receive the amount of demand that we need for a project, for FITO at a project, and respond to that and give the results to that project team. You know, I also see these drones, there's even a couple instances for them working on companies right now that are scanning and maintaining equipment lists inside of warehouses. And how I see this incorporating into construction is we get equipment from manufacturers all the time that we're going to input into a data center or something. And so we're looking to scan that with a drone and a simple QR code, instead of sending somebody out in the Arizona heat at 120 degrees and spending those hours on a day, we can put them to do something more useful. And then of course, incorporating LiDAR and accuracy into drones. Photogrammetry is great and it's come a long way, but as we see LiDAR becoming more and more readily available, what with all the new iPhones coming out with LiDAR in this small package, we're totally expecting to see this being incorporated into drones and everyday flights as well.
Wonderful. Thank you, Dean, for kind of telling us where we're headed with these tools as an industry. I do want to take a minute or two here to kind of dive into one or two of the questions that were submitted through the Q&A module.
Casey.
Okay. The first question we have is, do you share this data with the company you are building on each project?
Yeah, great question. It depends on the client and the contract and what it is, right? There's moments where we've done a thermal flight, we share that with them. So that way they have the same record that we have of what our structure was that we turned over and delivered to them. There's other things like we showed some of the earthwork calculation that Dean was doing for one of our earthwork projects, and we turned over the deliverables. So we turned over that picture showing kind of where we had cut and filled on the job site and then the associated quantities, but we didn't turn over that underlying data set. Since then, that particular project has actually reached out asking for it so they could see some of our earthwork activities in the area, and we've given it to them. We don't have any kind of policy that we don't share anything, but it just kind of depends on what the client wants and what their needs are. Hope that answers the question.
Next question, do you use drone and map or something else?
Sorry, repeat the, do we use drone and map?
Drone to map.
Drone to map. Okay, yeah, we Dean, you can speak to that question.
We use a software called Drone Deploy that allows us to set up automated grid missions as well as a ton of other things. And it kind of sets a lawnmower pattern over a given area, whatever we've determined it needs to be. And that allows us the flexibility and the results that we need. So there's a lot that goes into that, but we primarily use Drone Deploy. As far as the 3D scan, though, that is through the Skydio software. So kind of two different softwares, but for the majority of what we're doing, we're using Drone Deploy as our software.
Wonderful. Thanks, Dean. And thanks, Casey, for facilitating those questions.
I have one more.
I think we're out of time. We got to jump over to that next session, but I would love to be able to take some time and answer any questions that come up from this course and kind of a text-based approach after that.
Thank you, Eric and Dean from Sundt Construction. And yes, Casey, if you can just copy and paste those over into our green room chat, get the answers, and then you can post them back for the people to see.
Okay.
All right, so our next presentation is going to be by Joe Peters and Justin Wells of Esri. It is entitled A Complete Drone Solution and How to Get Started. Justin and Joe, take it away.
Yeah, thanks everyone. I'm actually going to pretty promptly here pass it over to Justin. So we actually both submitted abstracts for the next presentation, but Justin, being a member of our imagery and remote sensing team, has this teed up and he's going to take it from here. I just want to let everyone know I'm a solution engineer on Esri's local government team and I support Arizona. So I will put my email in the chat, and if you do have any follow-up questions about our drone capabilities, feel free to reach out to me as well as Justin. So Justin, over to you.
Thanks. Yeah, and I'm Justin. I'm an account executive here at Esri on our imagery and remote sensing team. So a little background in geology and other things, but I've really kind of found a sweet spot in imagery and remote sensing and GIS, and get involved with anything at Esri, specifically around imagery and remote sensing, as well as GIS and things. So more and more lately, that has become discussions about drones because more and more people are using it, discovering it, and it's just become a great way to collect data and things. So let me get my screen share going here. If you guys can see it now. And This was a lot easier when I had more monitors, but I think we're good to go here. So a complete drone solution. So we've heard a lot of different software applications today, I'm sure. And this is going to be basically one integrated software suite that basically the whole point of this is a seamless workflow, everything that you need other than the human and the hardware. So we try to take care of everything and make sure that, you know, our goal here is to make you as successful as possible with drones and growing your drone program, getting as much value out of your drones and your pilots as possible by taking a lot of making these workflows easier. So I know that's a lot to cover, but I've had plenty of coffee today.
Hey, Justin, this is Teresa. Sorry to interrupt. We cannot see your screen share if you're sharing a screen.
Oops.
That's okay.
Oh,
We see you, which
there we
is
go.
great. There you go. Now we see your screen.
So yeah, here's slide number 2. So that complete workflow looks like this. Starts with planning and capturing, mission planning, and fleet management along with that. Processing, managing, analyzing data. Somebody mentioned drone to map earlier. That's a part of this. A lot of this presentation is gonna site scan for ArcGIS. So just more of our cloud-based platform for doing this. But drone to map works fits right into this as well. And then disseminate and collaborate. So integrating with other systems, sharing, making it easy to share all the information that you're collecting rather than, you know, mailing somebody a hard drive or however we used to do it. And since we're, you know, a lot of times working with the construction cloud, we do integrate with the Autodesk Construction Cloud. So first off, why drones? A lot of our imagery question in the past has been a balance between spatial resolution versus temporal resolution, and then of course weighing that against cost, because as those two things go up, we get better resolutions, the cost goes up too. But with drones, we can kind of fill a gap where it's an inexpensive way to collect very high spatial resolution and up-to-date imagery. So some of the things that we run into when we talk to to folks in government here is people are using drones for land planning, environmental analysis, parcel mapping, facility and asset management, infrastructure and inspection, and project coordination. So a lot of this is centered around the construction, architecture, engineering, but we also talk to folks who are doing a lot with you know, large scale land management and things. And when we say process, I kind of want to define this really quickly. So we're talking about taking those overlapping drone images or video and creating orthomosaics, digital elevation models that includes terrain and surface models, thermal and near infrared multispectral orthomosaics, 3D point clouds and 3D meshes, inspection oriented imagery, and even 360-degree panoramas, making those easy to share for inspection. So just a couple of things that we've come out with lately that are kind of exciting that I wanted to share. One is 3D full motion video capture. So this has always been an exciting topic, but a difficult to achieve one because most drones are not collecting NISB compliant data that works with full motion video. Basically, full motion video allows you to project your video into map space, you know, view it in map space, or at least view the footprint like we see here, and even click on things within those features and get a feature out of that with an actual location from that oriented video file. So previously, most drones didn't do this. We're now able to capture drone video on most DJI, most of the common DJI and other common drones, and enable those with full motion video, even though they weren't made to do it. Another thing we've recently come up with is fleet management. So keeping track of all of the drones, all the batteries, the pilots, the Part 107s and other documents, You see in the bottom left, we can see this battery diminishing over time. We can click on a flight, figure out how they flew it, who flew it, what type of drone was used, what battery was on it, that kind of stuff. So all this is kept track of. You can add custom things into pre-flight checklists so that you're keeping track of things that aren't necessarily things that we've added. So I want to start with just mission planning. We use the Site Scan Flight Planning app. It has a number of really nice pre-made custom flights that are very easy to make. So starting with the area survey, just the classic lawnmower pattern, looking straight down. There's a crosshatch survey, which is like 2 overlapping area surveys with the camera pointed at an oblique angle. We found that 30 degrees or 35 degrees works best, but you can always change that. Notice all the little slide bars. You can change all the height and everything else, and all of those things along the bottom will update. So it'll update you to tell you how long your mission will take, your output resolution, the area, number of images, and number of batteries you need for the flight. There's perimeter scan for looking at the outside of a structure like a building or a tower, a water tower, cell tower, things like that. Vertical scan for flat, or even in this case like a bent facade of if we just want to capture one facade. Can also incline that for things like stadium bleachers, dams, and corridor scan. So we can fly along the edges of a corridor like a road or a river, and we can have the drone cross over and do one side, cross over and do the other, or we can turn that off and the drone will do one side, land next to us. We can carry it across and continue on the other side. So just in case you can't fly over that feature, you can turn that off, on and off. And then all of these flight plans, this flight app allows us to follow terrain. So it's using Esri's world terrain data with custom terrain coming soon, just to keep you at a constant elevation. So if you're working with terrain, you don't have to plan multiple flights. You don't have to worry about, am I going to go over that 400-foot ceiling or even crash into the side of my site, and just gives you consistent results across your area. So that's been really nice to use. It saved us a lot of time. So real quick, I want to kind of run a quick flight plan with you. Get the iPad going. So this is a dam here in California. So we quickly just draw a box around it. We're doing a standard area survey. It's going to automatically create this back and forth pattern. We're going to turn on terrain follow. We can see the drone do its, go up and down over 100 feet across this area. View it in 3D. We could even zoom in if there were any structures in the way. We could make sure that we can see our entire flight path to make sure that we have full line of sight. Name our plans. So if we want to fly this again, we can get a consistent flight next time. And then load that onto the drone. Once we get out there, it's gonna show us where we're at and update our flight path. We can go through a customized pre-flight checklist. Looks like everything's good to go. It's gonna show us any hazards, warnings from the FAA that we need to be aware of. And the next step, a safety briefing. If we needed a LANCE authorization, we could submit that here and get it back within a couple seconds. So looks like we're clear to fly. So once this happens, the drone's just going to take off. And this is the exciting part about the part they didn't tell us about flying drones, right? Just waiting for it to do its thing. But we can view this picture in picture, view the video, or view the map view, watch it fly back and forth. Take all of its images. Eventually it'll come back and land next to us for a new battery, or whenever it's done. In this case, we only needed one battery. So then we can check all these images to make sure that they're in focus. We got good images, remove any if we need to. or fly more if we need to. And then there are two options from there. You can upload these images to your computer, process them with drone to map, or throw them directly into the cloud and have them process and site scan for larger projects. It really helps, and really for a lot of things along the way. If you can process in the cloud, then it definitely helps. These large EC2 Amazon computers will auto scale. You get a lot of processing power and chew through that data rather than having your computer spin for a couple of days, for some of the larger projects. So once it's ready, it'll create all of those products we talked about. And we can, in this case with SiteScan, we can access it through the SiteScan web browser app. So it has a lot of cool tools that I can show you in a second, inspection and measurement and everything else. We've built a machine learning model, so to make finding these little ground control points really easy. These are the ones that we like to use, the little checkerboard patterns. If you're using something different, it's very easy to tag these or correct the tags later on if somebody's wearing a funny looking hat, or if there's a kitchen tile outside or something and it's mistagged something, you can go back and correct it. But typically it does a pretty good job of finding these. We've recently updated our processing engine. So we previously used different processing engines. Now we're using the Sure 3D Mesh engine, which is giving us really, this isn't the best example because it's just rocks and plants, but it's given us really good photorealistic results. You can kind of see the difference where we have kind of a blob on the top picture and more of something that looks like a plant on the bottom. So I can quickly show, this is what the SiteScan manager looks like. It starts out in a map view, but we can also go into a list view, search for our projects, or just click on it. We've got this this dam project we just did, excuse my language, but so we can see our dam here in our map on top of the imagery based map. Click any of these images and it's storing all of these uncompressed. Look through them all. Not the most exciting thing to look at, but a lot of grass. We can turn on terrain. This is actually the surface. Turn on any terrain lines. We can change the intervals there. We actually flew this twice so we can look at a before and after. Of course, nothing changed. A little exciting. And then we can view this in 3D. So this is the 3D point cloud. We've also got a 3D mesh, but this is the point cloud. This is really what you want to use for any measurements and things. So you can measure the height along this transect, or even pull out a subsect of these points. Use that to measure, view a profile view of this area. And then we can export the full thing or that subset, either the, all the original files, the TIFF files, the LAS, DWG, any PDF reports, things like that, the full files there. We want to do more than view it. So jumping into a different project here, this is an Earthworks project in Japan. This is kind of a cool project where we had plans from the engineers on what we were looking for, where we needed to remove earth and where we needed to move it to a new surface to create. So they got part of the way through this, and I guess they dug in the wrong spot and didn't realize till we flew a drone. So we can turn that on. We can do cut fill against a surface and terrain models, or we can change our ideal surface to a custom surface that we've uploaded. So we've uploaded the CAD file from the engineers, so we can see cut and fill against that instead of the surface. You can even create a subset of this data again, view it in 3D. see where we're at with our plans. And then we can, of course, pretty easily change this area, get a new surface. So doing all this very quickly takes a lot of the work out of combining these data sets. So lastly, I wanted to show a quick demo of our new building in Denver, Esri's new office building. So this was post-construction. We just wanted to kind of inspect it. So this is the point cloud. We've got a sign here. We don't know what it says from the point cloud, but if we orient the camera to look at it, then it'll give us the any images that captured it and prioritize the ones that are at our viewing angle currently. And it says no hard hats allowed, so we can remove that sign, create a report. It's just going to export a PDF and can send that to somebody. So lastly, the last step of this is disseminate and collaborate. One of the exciting things about being in the cloud is obviously the huge horsepower to the processing that we're able to use, the big AWS computers. But in addition, once that data is processed, it's already in the web. So it's very easy to copy a link, share the project with somebody privately or securely, privately or publicly. We can download all of those files to use in a third-party app like ArcGIS Pro, Autodesk. But it also integrates, we can push this stuff to ArcGIS Online or ArcGIS Enterprise directly from SiteScan and integrate it in with other applications like Web App Builder, dashboards, oriented imagery catalog, ArcGIS field apps. You can actually collect data using our field apps with your drone, or third party. You can push a lot of these projects directly into the Autodesk Construction Cloud. It's a recent name change, so it says Autodesk Connector. So a quick example of this is another new Esri building here in the Redlands campus. So we've flown this every week throughout construction. We've created some 3D meshes. This is kind of a dashboard to show inspections we can take out in the field. We've done inspections with the ArcGIS field apps. We see the progress of those on the bottom here, and we can click on any of these points and see what was inspected and the status of it. Updates. It has a 3D mesh. We've also got a building information model here, so we can slice and dice this building, see all the components, see all the things that we built, and we wanted to click on any of them, pull up a pop-up, see what any of these little parts and features are when they were installed, any information relevant about them. So we're also here to help with, with your drone program, where there's a people aspect to this as well. So, anyone who is using this technology, we like to help, with training and everything else, in-person training. So all of our SiteScan, everyone using SiteScan is connecting with us we can walk new users through all this stuff anytime. And I know I kind of flew through all of this, possibly a little too fast, but again, I'm Justin. Joseph is also here with me, and this is where you can reach us. So we're happy to talk more about this. We're enthusiasts, like a lot of folks on this call are. We enjoy talking about it, so we're happy to connect anytime to talk about your drone program and what you guys are doing and what you guys want, what everybody wants to do with drones. And thank you, Stacy. Thank you, Teresa. Everybody, thank you for giving us the time and letting us sit in and present and listen.
We have a few questions for you if you guys are willing to.
Yeah, absolutely. I think I got done a little ahead of the schedule.
Okay. So one question is, what is included in ArcGIS Drone to Map events in AGOL, ArcGIS Online? Good
question. We get this one a lot. So drone to map is, you can actually use all the flight planning that if you have a compatible drone, you don't have to use our flight planning in order to process on either of these systems. Drone to map is our local processing. So it's something that's installed on your computer like ArcGIS Pro is. And it has basically the same, it's creating all the same products SiteScan is, but it's doing it with your local processing. So a lot of the things that we talked about, like the cloud processing and sharing and integrating, some of those aren't available, but it is a great program for processing locally. It does tend to cap out because, you know, our computers are typically not as powerful as the Amazon Elastic scaling computers are that we can use with SiteScan. And it does use up local processing, so things like multitasking or even using your computer for other things while it's processing data. Photogrammetry can be a pretty computationally intensive. So, so SiteScan has some advantage in scaling in a number of different ways, but Drone to Map is doing a lot of the same things, doing it very well.
Perfect. Is SiteScan a standalone software, or do you need enterprise?
It can be standalone. It's obviously integrated. It's its own sort of program. You don't actually need anything. You just kind of log in and everything should work.
Yeah, one thing I'll add on to that is whether you use ArcGIS Enterprise or ArcGIS Online, when you log into SiteScan, it's a cloud-based product. You can actually add your credentials to connect to Enterprise or Online, so that once you've processed these products that Justin showed, you can actually push those data products over into ArcGIS Enterprise or ArcGIS Online, or download them to use locally if you'd like. And that's really nice for folks that use the rest of the ArcGIS system. So like Justin showed, you can add that to dashboards, put it into web applications, use it in ArcGIS field maps for folks that are out in the field. So you have these really high resolution based maps for folks doing field work that are maybe up to date and actually show some of the more recent construction that you're probably monitoring.
Perfect. What sensor does a drone need to accomplish this? I'm assuming that was at a time you were showing a slide.
Yeah, so we can basically work with any sensor, but if you're doing photogrammetry in general, you kind of want to hit the middle end. So when it comes to RGB sensors, the zoom lenses are not going to really work for you because you're too far zoomed in. It's hard to get enough overlap to do photogrammetry with the zoom lens or with the zoom sensor. And on the other end of that, the wide angle fisheye lens sensors are not good because they distort the image too much to do any triangulation. Other than that, you can use any sensor. When it comes to thermal sensors, some of the lower end ones, so thermal sensors are pretty expensive. It's hard to image in high resolution with thermal, and we need at least about 640 pixel rows in order to do any sort of triangulation and photogrammetry. So with the thermal sensors, some of the less expensive ones are very low resolution, and we can't do much with those. Other than that, any sensor should work with Drone to Map or SiteScan.
Perfect. You answered one of the questions about working with ArcGIS Portal. I have a question about that. When you're sharing the data via ArcGIS Portal, are you copying the data over and you're storing it on Portal, or is it just consuming the web service right SiteScan?
So it will push the web services out. So it will send either whatever you want to send to either of those platforms. So you could send tiles, scene layer packages, or you can publish full files to either of those. It will move the data over there. You can also share directly from SiteScan. So you could click copy link and share it with somebody. SiteScan does include unlimited viewer licenses for SiteScan. So if you wanted to share privately, you just invite somebody to create a username and password and then share that project with a specific user.
Yeah, so
Oh, I'm
Site-
sorry.
Oh, I was just going to say, so SiteScan kind of has its own, data model on the back end, and we've connected ArcGIS Online and ArcGIS Enterprise. So when you do actually share to either ArcGIS Online or ArcGIS Enterprise, at that time, items are created in those environments, and those items reference, the layers themselves. So it actually copies the data over and creates those layers in either ArcGIS Online or ArcGIS Enterprise.
Perfect. And the last question is, what is the drone accuracy that you are shown to us? Or what is the model?
The accuracy of the products coming out of this.
Yes.
So that's I think the full answer to that would take a long time to come to. It really depends on what you're doing. So so if you're using like an RTK enabled drone, it is finding its position, and some of them are correcting images. Some of them are not actually writing those corrections into the image file. So you may or may not get, from 10 meters down to a couple of meters just with the RTK drones. If you're using ground control points, then this is going to be, it's going to be as accurate as you can get those ground control points, usually within a couple centimeters. Less than 2 centimeters is achievable. You always have to add your ground sampling distance to that error in order to, and that's all referring to the accuracy placed onto a projection. If you want to combine multiple data sets, it's as close as you can tie those two things together. So you can actually tie two images together and get it much more accurate than that, down to your ground sampling distance. And also keep in mind, if you're measuring something, it doesn't matter really how accurately it's placed on that model. When you measure something, it's usually accurate to within a couple of percentage points, or maybe even less than a percentage point with the measurements. So totally depends on what you're using and kind of how we're defining accuracy.
Thank you, Justin and Joe. That was a great presentation. And thank you, Eric and Dean, for the presentation before that. It's the cutting edge of what's going on with all the LiDAR, UAV, flyover, ortho data. Quite informative and great. Just a few things. Thank you for attending this session. If you notice on the right-hand side, there is a little button for survey. We'd appreciate it if you would complete that survey after this session. That helps us figure out what we're going to do for next year and get your feedback. Very important. Recording of this session is going to be available in about an hour and a half. And if you want to connect with any of the speakers, you can do that, or any of the attendees. You can do that in the community attendees listing. Remember, if you do not find them, it's because they did not unhide them. So I'm going to say that to all the presenters here. If you go into that community attendee and unhide yourself, then people will be able to contact you. So thank you again so much. And I greatly appreciate it.